How can you capture the concept of clouds in a giant metal sculpture? I wanted to make something light and open that feels like it's floating in the air, but with a rigid mathematical structure. Begin with a rhombic tricontahedron. This polyhedron, shown in red, is made from 30 identical rhombi. And in the 30 extended face planes of these rhombi, I designed a flat part which fits with itself in many ways. Each meets 6 other copies of itself at different places along its length. The ideas underlying this come from a branch of geometry called polyhedral stellations. Now, we'll take the one blue shape and distort it into 4 new shapes. We do this by squeezing the spherical sculpture to half its height. The amount and direction of the transformation for each shape depends on how that part is oriented relative to the vertical axis of compression. But it's a linear transformation, so planes map into planes and their lines of intersection map to lines. A key point is that the new shapes are still planar, so I can cut them out from flat material. I first made a small wood model to make sure I knew what I was doing and verify I had calculated all the lengths and angles correctly. I can also tell for sure at this point that I really like the design. It combines mathematical underpinnings with a naturalistic feeling. Then I made a full-scale wood prototype with the help of lots of student volunteers. This also lets me test out the sequence of assembly, the parts joined with cable ties that go through small laser-cut openings. There are 2 orbs, each 5 feet in diameter, mirror images of each other, congruent but made as left-hand and right-hand versions. They're hanging in the Wang Center at Stony Brook University. Now I'm confident enough to cut metal, 50 pounds of aluminum, with special brackets bent to all the required dihedral angles. I did a quick test in my studio of 1 orb to verify everything fits. And finally, the actual assembly on site. There were well over 3,000 parts, including brackets, nuts, bolts, and washers. First, I explained to my crew of volunteers the steps for making the 3-part modules. The 60 pieces of each orb can be assembled as 20 modules of 2 basic types, but there are plenty of ways one might accidentally misassemble them, so it's much trickier than it looks. After orienting the parts and figuring out which holes to use, they're joined together with stainless steel hardware. There's lots to do, including 720 nuts to tighten, but you get into a rhythm, and pretty soon you're an expert team, putting everything in its place. As we add modules, it grows larger and you get a good sense of the form. Mathematical ideas of planarity, parallelism, triangles, pentagons, intersecting planes, transformations, chirality, and symmetry all enrich the overall organic structure. Finally, the last module goes in. Everything fits together beautifully. There are no more loose ends, and you have an enormously satisfying feeling of completion. 2 eye bolts are waiting in the ceiling. We just need to shackle the sculpture in place. I think it looks pretty cool up there. You'll probably discover new aspects of its structure from different vantage points. If you want to see clouds in person, it's in the lobby of the Gerald Fischbach Auditorium in the Simons Foundation building in New York City.